We use Wi-Fi pretty much every single day, right? But what do we actually know about it? Like, what do all those weird numbers mean? Well, today we're going to dive into the secret history of Wi-Fi, decode those confusing numbers, and uncover the truth behind our wireless world. So, have you ever looked at the side of a router box, or maybe even your phone's network settings, and seen something like 802.11ax? It just looks like a jumble of letters and numbers, like some kind of secret code. It's confusing, right? Well, stick around, because we're going to crack that code wide open. All right, to really get what those numbers are all about, we got to rewind the clock, way back to a time before Wi-Fi was even a word. See, the whole thing started with a big problem. You had all these new wireless gadgets, but none of them could talk to each other. It was like they were all speaking different languages. Okay, so the first ever wireless data network, it actually popped up in Hawaii way back in 1971. Crazy, right? But the real push for one single universal standard didn't start until the late 80s. A company, NCR, went to this big engineering organization, the IEEE, and said, hey, we need to get everyone on the same page. And that's what led to the 802.11 working group. See, that's where the name comes from. The very first standard they released, back in 1997, was, well, it was a start. We're talking speeds of just 2 megabits per second. So once that first standard was locked in, boom, the race was on. From that point forward, the story of Wi-Fi is basically just a relentless, pedal-to-the-metal pursuit of more and more speed. We're talking about the journey from those first sluggish megabits to the absolutely mind-blowing gigabit speeds we have today. And the first big moment for us, for regular consumers, was in 1999. That's when 802.11b came out, hitting 11 megabits per second. Now, here's a fun fact. A faster standard, 802.11a, actually came out at the same time, but it was way more expensive. And as you can guess, the cheaper one won. So it was really the slower 802.11b that first brought Wi-Fi into our homes. Then, fast forward to 2003, and we get another big jump with 802.11g. This was clever. It took the speed of that expensive A standard, 54 megabits per second, and brought it to the much more popular and affordable 2.4 gigahertz band that everyone was already using. Suddenly, fast wireless was something pretty much anyone could get. Okay, but 2008? That was a huge leap. 802.11 showed up and introduced something called dual-band technology. It could use both the 2.4 and the 5 gigahertz frequencies at the same time. Think of it like opening up a whole second highway for data. And the result? The maximum theoretical speed shot up to a whopping 600 megabits per second. And just when you think it can't get crazier, the numbers just keep climbing. In 2013, 802.11ac hits the scene, and it's promising a theoretical speed of nearly 7,000 megabits per second. I mean, that's multi-gigabit wireless. But here's the thing. If you went out and bought one of those fancy routers, you probably noticed something: you weren't getting anywhere near that speed. So what gives? And that right there brings us to the heart of the Wi-Fi mystery. It's time to pull back the curtain on those incredible speed claims. We're going to talk about the big difference between the number printed on the box and the actual speed you get on your laptop. So the secret, it turns out, is a technical term called the PHY rate. PHY stands for physical. So this isn't your download speed, not at all. Think of it as the absolute top-of-the-line, best-case scenario speed the hardware can theoretically achieve, but only in a perfect sterile lab with no interference. It's the on-paper speed. Here's a really great way to picture it. Imagine a train. The fizzy rate is the top speed of that train. Let's say it can go 100 miles per hour. But what you really care about is the cargo inside the train cars, the actual data getting from point A to point B. And that real-world delivery of cargo? That's called throughput. And just like in real life, it's always going to be less than the train's maximum possible speed. And this table, it just lays it all out, plain and simple. Just look at 802.11ac. The max theoretical speed, the phi rate, is almost 7,000 Mbps. But what do you typically get in the real world? More like 5,000. And even that is under pretty ideal conditions. It's proof positive that the speed on the box is not the speed you get. So, okay, why is there this gap? Well, it boils down to 3 main things. First, no hardware is ever 100% efficient. There's always some overhead. Second, not all devices are built the same. Just because 2 routers are certified doesn't mean they have the same top-end parts. And finally, you've got the real world. Things like walls, how far you are from the router, how many other people are on the network, even your neighbor's Wi-Fi network can slow you down. Okay, so after years of everyone being confused by these 802.11 whatever names, the industry finally said, okay, enough. There has to be a better way. So in 2018, the Wi-Fi Alliance stepped in and thankfully decided to make things a whole lot simpler for the rest of us. So instead of making us memorize a code name like 802.11ax, they came up with a brilliantly simple generational system. 802.11n, that's now Wi-Fi 4. 802.11ac, Wi-Fi 5. And that confusing 802.11ax, just Wi-Fi 6. It's so much more intuitive, right? Bigger number, better Wi-Fi. Simple as that. And they didn't just give us new names. They gave us these handy little symbols, too. You've probably started seeing these pop up on your phone or computer when you connect to a network. They even went back and unofficially gave names to the older standards, which is why you might occasionally see references to Wi-Fi 1, 2, or 3. But of course, the story doesn't end with Wi-Fi 6. Not by a long shot. In fact, innovation is speeding up. And it's not just about getting faster anymore. It's also about making our connections way more secure. So just how fast is Wi-Fi 6? Well, it boosts that theoretical max speed to over 9,600 megabits per second. Pretty incredible. But its close cousin, Wi-Fi 6E, does something maybe even more important. It opens up brand new frequency, the 6 gigahertz band. Remember that highway analogy? This is like building a whole new completely empty superhighway just for Wi-Fi 6E devices. It's a huge deal for cutting down on congestion. And just when you think, okay, that has to be the limit, boom, Wi-Fi 7 arrives in 2024. And just look at that number. A theoretical speed of over 46,000 megabits per second. That is just, it's almost hard to comprehend how fast that is. It really shows you how relentless the pace of this innovation has become. But like I said, speed isn't everything. You've got to have security. And that's been its own journey. We started with this standard called WEP, which turned out to be super easy to crack. So then we got WPA, and then the much better WPA2, which is probably what you're using right now. But now, with Wi-Fi 6 and newer, we have WPA3, which is a massive step up in encryption and security for our networks today. Okay, so here's a really important question you're probably asking. Do I have to throw out all my old devices when I get a new router? And the answer is a big, resounding no. One of the best things about Wi-Fi is that it's designed to be backwards compatible. So your shiny new Wi-Fi 6 phone can still talk to your old Wi-Fi 4 router, no problem. They'll just connect at the best speed they can both handle. In this case, Wi-Fi 4. It just works. So think about that. We have gone from just 2 megabits per second to a theoretical 46,000 in just a few decades. We're talking about speeds today that the creators of that first little network in Hawaii couldn't have even dreamed of. It really leaves you with one final, exciting question to think about. Now that we have speeds fast enough to download a whole movie in seconds, what's next? What kind of amazing new technologies and experiences is this next generation of wireless going to unlock for all of us?